Okay, this is section 1.5, and today we're going to talk about the composition of functions. This is kind of how we just take two different functions and put them together. And we usually start out kind of simple with kids. We talk about just plugging in f of 3. So if I were to find f of 3, I would put a 3 into the equation. So I'd have 3 squared plus 3, which is 9, plus 3, which is 12. If I said f of a, you would plug an a in. So this would become a squared plus 3. Same thing with a b, it would just change the variable, so this will be b squared plus 3. And the last one, we're going to take this whole thing, this a plus b, and we're going to plug it in right there. So this one will be a plus b squared plus 3. So not a big challenge. If I gave most of you that type of question, I think you could handle it just fine. Moving on, with a little bit of notation as far as our compositions or our adding and subtracting are going to go. So just as two numbers can be added, subtracted, multiplied, and divided, two functions can do the same thing. So if I give you two functions, you can do all the four operations on it. And what addition would look like is you would just take the two functions and add them together. Another way to write that is to say f plus g and then of x. So it's just two different ways to write it. Subtraction would look the same, just with a subtraction sign. So I'm just talking about being able to take two different functions and combine them. Multiplication, you'll just end up doing a lot of foiling. Put parentheses around that guy. And lots of distributing. Or you can do an FG of x. Division, you want to do what you can to simplify. Sometimes that means factoring things so that you can cancel different items. So division is the one to kind of watch out for. So we'll do a couple of examples here. These are the three functions we're going to use, and we're going to do 4 different problems with them, one of each. So the first one says addition, so I'm going to take I'm going to take g and add it to h. So I'm going to take x squared minus 2x minus 8, and I'm going to add it to 3x minus 12. So just combining like terms, I have x squared, my x's come together and make an x, and then my numbers come together and make negative 20. Next one we're going to subtract. What you have to watch out about subtraction is this minus sign, and you need to make sure that you subtract the entire h function. So that negative has got to distribute to both of those. So x squared plus 2x minus 3x plus 12, and then just combine these two guys together. So x squared minus x plus 12. Next we're going to multiply, a little bit of foiling involved. We're going to take g, so this whole thing, x squared minus 2x minus 8, and when we multiply it by this one, we're going to have to do some foiling. I highly suggest using those lines so that you keep track of what you have multiplied and what you haven't. So the first one will be 3x cubed, and then negative 12x squared, negative 6x squared, plus 24x, and then inside negative 24x, and plus 8 times 12 is 96. Running into number 4 there a little bit. Now all we have to do is add like terms up. So I got 3x cubed, and these guys right here make 18x squared. And these guys actually cancel each other out. I got one positive, one negative, and then a plus 96. The last one we're going to do has a little bit of division in it. So this is where you kind of want to watch and see if you can factor anything. So x squared minus 2x minus 8 over, and this time we're going to use f, which we used back here. So x squared plus 2x. And now I'm going to factor the top. So this would be x minus 4, x plus 2. And then on the bottom, I'm going to take out an x. So this guy has 2 x's, this guy has 1. I'm going to take 1 out. That would leave me with an x plus 2. And then I can cancel, and I'm left with x minus 4 over x. That would be ideal, is if you do a little bit of factoring and then cancel some stuff out. The next thing we talk about is composition notation. Now we're talking about taking a function and putting it inside of another function. So not just adding, subtracting, multiplying, and dividing them, but actually putting one function inside of another. And you saw this notation last year. I don't know why I started out like that. So f composed with g, and it kind of looks like fog. So that little thing is not an O, it's not a multiply, it's actually open, and it means composition of a function. And then of x. A different way to write this is to go f of g of x. So you're literally saying, I'm going to put the g function inside the f1. So instead of doing f of 3 or f of a, we're going to take the entire g function and plug it in. Oops, sorry here. So another way of combining two functions is to form the composition, that's what we're talking about, with one with another, essentially plugging one into the other. So just doing two examples here. If I have x squared and then x plus 1, a composition, and we're going to do one both ways. So we're going to do f of g of x, and then we're going to do g of f of x. So this just means f is on the outside, g is on the inside. So I have to take g and put it into f. So what I'm literally doing is doing f of, and instead of g of x, I'm going to do x plus 1. So instead of having that sit there, I replaced it, I took it out and replaced it with x plus 1. So now I'm going to take x plus 1 and plug it in right here. And you can FOIL that out. You can leave it like this for right now as well. The key here is to be able to get one function plugged into the other. So why don't you try the next one, pause the video and try it before I do it. This one's going to take f of x, because that's the one on the inside, and we're going to plug it into g. So we are doing a g of x squared. That's what f was. I plugged it in, substituted, because these are the same thing. And then I am going to take the f function and plug it into g. So the g function is just x plus 1, but instead of this x, I'm putting the f function. So it'll be x squared plus 1. So the big thing with compositions is that you need to be able to take one function and plug it into the other one. Next, we're going to do a couple more examples here. So f of g of 4 would be like this, f of g of 4. So the first thing we're going to do, if you kind of work inside out, is going to be put the 4 into g. So kind of leave the f there, but we're going to put the 4 into g, and if I do 6 times 4, that's 24. Now I think you could do this problem. If I had set it up for you this way to start with and said, what's f of 24? I think you could have done that pretty easily by plugging in a 24. So 24, sorry, waiting for my calculator here. 24 times 24 is 576 plus another 24. So 600 all in all. The next one doesn't have any numbers, so we're just going to be dealing with the function here. So f of g of x. So I'm going to go f of g of x. So my g function is right here, so what I'm doing is f of 6x. So I'm going to take 6x and I'm going to plug it into these x's. So I'm replacing them. So it might help if you put parentheses where the x's are, knowing that you're going to plug something in there. So now I've got 6x and 6x. So if you simplified this a little bit, this would be 36x squared plus 6x. Next one is going to go backwards. So this is g of f of x. So g of f of x. So I'm going to replace this first with whatever f is. F is x squared plus x. And now I'm doing g of that. So instead of g of 3 or g of a or g of b, I happen to just be doing this bigger thing. So wherever there is an x, I am going to put x squared plus x. This is not easy to do. It's hard to get your head around it. Lots of students will put the number right next to the x. So they would have done a 6x and then all of this stuff. Make sure that you're actually replacing the x. That's your job. So if I asked you for g of 3, you wouldn't go 6x and then a 3. You put the 3 in the x's spot. So a couple more here. Again, I would pause the video, give these a try before you see how I do them. This is f of g of 4. So first I'm going to figure out if I were to plug a 4 in, what would happen. And so a 4 into g, 4 squared would be 16. And then I'm going to do f of 16, so I'm going to put a 16 right there and get 13. Next one is f of g of x. So f of g of x. Oops, I just repeated what I wrote. Sorry. F of, and then g of x is x squared, so I'm going to put that right there. And then this is what's going to go into f. So wherever there is an x in f, that's what I'm putting there. So this will be x squared minus 3. Last one is just flipped, so g of f of x. G of and f of x is x minus 3, so I'm going to put that there. And now that is what I'm putting into g. I'm going to take this stuff and put it right there. So x minus 3 squared, I could FOIL that and get x squared minus 6x plus 9. Usually students don't have a problem with the adding, subtracting, multiplying, dividing. It's when you get down to this composition stuff and trying to get one function inside of the other that usually causes kids problems. Try and remember or try and remind yourself it's kind of like doing g of 4. And if I asked you for g of 4, what would you do? And you always will tell me, I would plug in the 4. That's the same thing you're doing here. You're just plugging in something different. You're going to plug in a whole function.